required in this project. So because we all had such focused skills, we didn't have any real managerial oversight. And this lack of oversight caused us to really have to divide and conquer. And so here are our roles, and we each divided it up into groups of two. But we had no central oversight, as I said, and that really caused us great challenges towards the end, as you will see later. First, I'm going to talk about part of the biomedical engineering known as bioengineering, which has to do with studying biological systems, how they work primarily in the human body. And this mainly worked in our prosthetic arm, you can see over at your left. And this arm had a basic function of lifting a cup and having a wrist to turn it out. And we really found that this was very difficult because it's very difficult to replicate the complexity of the human body and the muscles and tendons in the arm. So now Jason is going to talk more about biological engineering.
Clinical engineering is when engineers work together with mechanical engineers to develop human body systems. So it may not be something like an arm, but it could be something that analyzes tissues. So using the clinical engineering with doctors, you can work together with the doctors and engineers to develop technology that will help the hospitals and the medical fields. Medical applications, there's tissue engineering, which is basically developing tissues from basic cells. And then there's also improved surgery that can happen through teleoperation or robots of some kind that have minimal invasive surgery versus open heart surgery. You could have 3 punctures in the chest, and then 3 leads from a robot will go in, and then you could do the whole heart surgery without even opening up the person's chest.
So as Duncan said before, Jason and I were responsible for the iRobot, and here this relates a lot to computer engineering because we actually got to program the actual iRobot's very specific needs, and furthermore, we experienced problems putting the programming into the robot and then executing that, and this gave us a lot of experience knowing what we need to do if in a certain situation we needed to rescue somebody. The design, there wasn't much design other than it was an iRobot, but the programming took a lot of changing, and if one little thing was wrong, then the whole program didn't work. So that took a lot of work.
So in our group, we had a few main difficulties. There was a lot of hostility in my group. We argued a lot. I don't know if you guys saw, but we argued a lot, and that wasted a lot of time. It wasn't even necessary. And so if we could go back, we would probably figure out a better way to get along because it wasted so much time.
And also, we had many difficult. This is the final project. The product. So, we also had many difficulties regarding materials and computer, and also time. As you guys all have to do, we have to do 3 robots in 2.5 days or something, and we don't have enough computers to work with the programming and the Vex and also the Lego car. And for me, I'm responsible for the Lego car, and I found it really hard to work in 2 different spots and communicate through the phone and the Dropbox and all that stuff. And it was really hard because I can't visually see the turn, and then I have to program that, and it's really difficult to visualize it in my head. So that's one obstacle we face. And also another obstacle we face is for the Vex, because we had a lack of material, so the Vex on the mechanical aspect of it did not quite fit or work, and so that could be a problem when we are presenting. And I don't know about the iRobot, so yeah. towards our final project, to the upper left, it's the Lego car, the iRobot, and the lower one's the mechanical arm.
On. And this is a video of our one attempt of our robotic arm, and it did, as you can see, it did turn the cup over, so it technically is working. And then we can explain some of our failures from lacking materials, like Stan said, computers, and programming errors. So, yes, there are programming errors in the VEX parts. So, yes. Okay, thank you, and that was our presentation by Group 2.
Who's going first?
The robotic arm will go first.
Okay, let's look at your arm.
We love to volunteer, so. Yeah, we'll take that out.
Alrighty.
Plugged in. Hopefully they're plugged in correctly. Alright, wait. Okay.
Hold it.
No.
Yeah.
Alright, 3, 2, 1, go. Alright, try that again. Okay. Okay, go.
Hey.
You're holding it.
No, it was holding it. Well, there.
Oh.
Yeah, we're waiting for 5 seconds.
Wait.
Yeah.
Just so you do know, it can pick it up by itself on a good day.
Wait, did the wrist move at all?
Yeah, it rotated.
Yeah.
Okay.
Alright, let's look at your Lego.
Lego.
Oh, no. I want to see it.
No. Doesn't work. Don't hate. You have a good arm. You don't need to hate.
Alright, go ahead.
So,
Oh.
Yeah.
Come on.
Go back.
Turn that way.
Let's do it.
it got confused from your lines, man.
No, it helped it.
Actually, it did help.
Yeah, it helped it.
Come on. You can do it.
Oh, it's gonna do it.
Oh, I didn't think it
Yes!
Hey.
Yeah!
Come on. You can do it. It's stuck. It's the board.
Hey!
What? He didn't do anything.
Pick it up.
That was cheating.
So put a little asterisk.
Oh my god!
It's gonna do it.
I'm the last one, man!
Ah, you did it.
Yo.
This is the first time
You did it. What were you
Oh,
worried
the last
about?
one. It
Good job.
was the last programming.
Dude, ours is not
It was the last one that
Oh.
Thank you, Edmund. Yeah.
I was gonna take like 20 tries before we get done this.
Got it.
I didn't even have like a trial run.
Is he on?
Yeah.
Is there anything you want to adjust?
Are we putting this on 8 feet?
No. Oh, you got 2 of them?
No, that one's off.
Just adjust it.
Middle range.
I don't know how you
Yeah,
want
it's
to
going backwards.
Yeah, you just. I mean, you just cheated.
No.
Guy, come.
You can Yeah, we did it right.
Come to you. Wherever you want. Oh, let me slide.
My mom. That's cheating. It's just like
That's
straight.
what.
Yeah.
Look at
that
the
means you
block,
found
so
it.
it like.
Well, that was easy, yeah.
Well, yeah, that's what I was saying. If you were gonna do it.
How do you know when it's found it?
What?
How do you know when it's found it?
that. When it starts turning in a clockwise fashion, like searching, it means that it's searching for the home.
Okay.
It's working in the function cover dot from the demo list. So once it finds the signal, most likely when it comes back around, it'll start its way back.
Got stuck.
So yeah, it's not really.
I think it's going the wrong way.
Don't find it eventually.
I don't get what you're supposed to do.
Oh, yeah, found it.
Yeah, but at this time, like, there's a guy under a pile of rubble on fire, like, it's terrible pain.
It could have been like before, where the guy had to die before it was that there was a
What?
person there.
It's a useless robot.
Hey, it's making it.
Given
Maybe.
enough time, you
Yeah,
just if you have something
Come
with a
on.
bumper sensor
You're
that
almost
just keeps
there.
coming.
Found it. I found
You
it.
can do it. You can do it. It's going. It's going.
Sir, I have something to report. I found someone.
Please make it in, otherwise it's
Woo!
gonna be.
Yeah! Success.